fertilizers, and I'm going to talk our applied research result for the past 2 to 3 years in summary 4. So the low desert Arizona is characterized by hot summers, warm winters, and dry climate. This is not always bad because it is enabling alfalfa crop growth, particularly throughout the year here in the low desert. However, there is only little to no precipitation. So alfalfa is fully irrigated, particularly by surface flood irrigation. And the soil is alkaline and calcareous, where cations are very high. So in alfalfa production, nitrogen fertilizer is generally not applied because alfalfa has nitrogen fixing nodules. And as it's known, K is assumed to be abundantly available in the low desert Arizona. So potassium is not typically applied also to crops. Though alfalfa plant removed large amount of potassium from the soil, where 1 ton of alfalfa production removed about 50 to 60 pounds of potassium. The soil is low to medium also phosphorus, so phosphorus fertilizer is commonly applied. The variety under production is non-dormant or very non-dormant and extremely non-dormant under the category false dormancy class of 8, 9, and 10. This means the production is continuous without any rest. Also, we can conclude that the intensive production systems in Arizona gives to highest tons per acre, the highest in the nation, than average production in the United States, which is 8.4 tons per acre, from 6 to 10 cuttings. And also frequent alfalfa harvesting is practiced that may lead to reduction in yield and stand persistence. So what are the main issues or problems confronting us here in the low desert? The stand longevity issue is one of the big problems in our condition, which means the stand is not persistence, and there was loss, or there has been loss after 3 years in production system. So the yield reduction is another issue because of this stand loss. Quality issue and autotoxicity issue due to aging is another problem. Because of that, to remedy this stand loss, excessive use of single nutrient, particularly phosphorus, is practiced. Rather than re-establishment of the stand, which is costly, farmers or growers use excessive use of phosphorus. But as incrementing cost of fertilizers, these have to be carefully seen, and there are also grower interest that is higher quality yield, but the environmental consideration is on the other hand. That means excessive use of single nutrient will lead to pollution of the environment. Generally, when we see in the low desert no limited information on balancing nutrients of fertilizer, particularly potassium and phosphorus in alfalfa production. if we see the symptoms of potassium, the margin of the leaf is dotted with brown or yellow color, and finally brings to the days of the leaves in the long term. So with that being our justification, with the main objective of to determine the yield response of irrigated alfalfa to virus blend of phosphorus and potassium fertilizers, and to assess the effect on soil and plant test P and K levels, where K is not lacking, we conducted research under field condition and relatively also under controlled environment. The methodology we followed are as follows. Our source of fertilizers were monoammonium phosphate, which is 11,520, and potassium chloride, which is 0,060. And rate of application was 0,192 and 240 pounds per acre of phosphorus, and 0,167 and 500 pounds per acre of potassium chloride. This is the field layout that we conducted at Maricopa Ag Center with 400 square feet area of plots and 20 by 20 widths, with 5 alleys between plot and 10 feet between replication. So we combined the MAP and KCL, or PTO5 and KTO, and get 9 combination treatments. And this was replicated in more or less controlled environment under drip irrigation here in Phoenix, Arizona, by installing tube trials, planting the materials, the seed materials, and getting applied with combination of phosphorus and potassium. The soil standard test indicated that the pH at MAC and the tube trial is very high in tube trial, particularly 9, and in MAC it is 8.2. The potassium is high in both, but in tube trials it is less than at MAC. The nitrogen is higher than the MAC in the tube trial. And the sand content of the trial is particularly higher in the tube trial. As you see, 72% of the soil is, the soil content is sand. That means the classification of this soil is sand clay soil, clay loam under Maricopa Ag Center, and sandy loam under the tube trial. We took 8 cuttings in 2018 and 6 cuttings in 2019 from MAC, but 6 cuttings in 2019 and 5 cuttings in 2020 in tube trial. Hay yield was adjusted to 12% moisture, soil samples at 6 inches depth collected, soil P and K determined, and the subsamples of 48 shoot per plot were also collected, and phosphorus and potassium concentration in the plant was determined. Here is our results for 2 years at MAC. We got significantly different hay yield when fertilized plots compared to unfertilized plots. The rates 100 and 125 PTO5 and KTO is not significantly different between each other after the January cutting. But in January cutting, the highest rates gave significantly higher hay yield as compared to the lower rate as well as unfertilized plot. So after January, the fertilized plot gave significantly higher yields than unfertilized plot, except in June and in August. The final total hay yield of the 8 cuttings was significantly different from unfertilized plot, but the two rates are almost the same, where the 100-pound PTO5 gave about 17.2 tons per acre, and the same yield obtained from the highest rate of application. This was in 2018. In 2019, similar results was obtained, but we didn't get any significant differences between the two rates, although the two rates significantly different from the unfertilized plot in producing or giving hay yield. So when we see the total production of hay, it is almost again similar in 2019 also, where we got non-significant difference between the two rates, but the fertilized plot significantly give higher yields than unfertilized plot. When we see the sand loamy soil, the tube trial, our result indicated that almost similar to the field condition. In February, the highest rate of PTO5 gave significantly higher yield as compared to the lower rate or unfertilized plot. After February, there was no significant difference between the two rates, although the fertilized plot gave significantly higher yield as compared to unfertilized plot. The same yield result or similar yield result was obtained in 2020, where significantly higher yield was obtained from fertilized plot, but there was no significant differences between the 100 and the 125 across the cuttings, starting from December and last June. When we see the combination, we saw that the last one is just only for phosphorus applications. But since there was no significant differences among the potassium rate of application, we didn't include in our presentation. But the combination, which is very important, and the objective of this research indicated that fertilizing alfalfa with 125 pounds of PTO5 and 100 pounds of KTO resulted significantly in higher hay yield than all unfertilized, the unfertilized plot, both in 2018 as well as in 2019, the average being also significantly different from the unfertilized plot. So in this case, under field condition, both in 2018 and 2019, the 125 and 100 gave the best result. Does it occur the same in sandy loam? Let's see it. This is the tube trial on a sandy loam soil. So similar happened in this condition, which justifies the 125 and 100 KTO gave the best results and can be workable. So 125 PTO5 per acre and 100 K2O pounds per acre give the best results in this study. Individually, the phosphorus and potassium increased yield both at MAG Ag Center and in tube trial. Percent yield increment at MAG in 2018 was 8% yield increment as compared to unfertilized plots. And almost similar in 2018, the 100 and 125 PTO5 pounds per acre. In 2019, in the 2 years, the 100 gave only 6.5% yield increment as compared to the one obtained at 125, which is almost again 8% yield increment. A slight yield increment was also observed in potassium application. In 2018, we obtained 4% yield increment in both 100 and 300 potassium. However, in 2019, the yield increment decreased at the highest rate of fertilizer application. So the 100 application gave more yield increment than the highest potassium application. This is at MAC. In the tube trial, similar trends obtained, but high percentage of increment. This is the phosphorus increased about 26% at 100 PTO5 and 33% at 125 in 2020. But in 2019, 23% yield increment and 28% yield increment obtained as compared to unfertilized plot. Potassium also increased yield similarly, and similar effect was also observed here in tube trial. In 2019, potassium increased almost 6% in 100 and 5% in 300 application. But in 2020, 9% increment observed in 100 potassium K2O pounds per acre, and very less increment obtained at the highest rate of potassium application. So highest rate of application does not have any significant yield increments when we see both phosphorus and potassium. When we see the combination of, if the combination effect of this phosphorus and potassium, the yield increment is higher For example, at MAC, about 13% yield increment obtained when you give 125 PTO5 and 100 KTO as compared to unfertilized plot. And then any combination give really a good result as compared to unfertilized plot. But similar to the previous result it is 125 and 100 combination that gave best results. In tube trial 2, the difference is the percentage of increment. Otherwise, similar result is obtained, but the 125 in both conditions also gave good percentage increment. So here it is about 42% increment as compared to unfertilized plot. Here, the balanced fertility synergetic effect is summarized. This is the average of 2 years for 2 trials. So when fertilizer, the combined fertilizer related to unfertilized plot, it gives 14% yield increment and 12% yield increment in 2019, the average of 13.5. The combined fertilizer or the blended fertilizer over K alone gave the yield advantage of 8.3% in 2018 and 8.4% in 2019. The combined fertilizer or the blend fertilizer gave more yield than the soil P fertilizer. In 2018, 3.6%. As we go in 2019, 6% yield advantage, more than the P alone. So the PK combination over average of P plus K give synergetic effect, in fact, which is 5.9% over the average of each individual alone, and that increment increased in 2019 about 7%. This holds true also for the tube trials, where 22% in 2019 obtained where PK over average P plus K gave 22% and 26% in 2020. So combination of balanced fertility synergetic effect occurred in such cases. P is at 125 pounds and K is at 100 pounds. These are also beneficial effects applying fertilizers to Olsen P, where in fact it is around deficient level in March, a little bit more than deficient in June, and again go to deficient level in September. But still the fertilized plot is greater Olsen P as compared to unfertilized plot. The plant P also increased from March to September, where fertilized plot had high PO4P contacts as compared to the unfertilized plot. This all is also in tube trial, but in tube trial, the February unfertilized and fertilized plot are higher than the other conditions in April and June, because this is controlled environment and it is a tube, so there is no problem of warming or hot since it is in a tube, as compared to the September or in the field condition. The plant content of PO4 is increased from February to June, where fertilized plot highly increased than the unfertilized plot. So the wholesale P and the plant P is directly and positively and significantly impacted alfalfa yield. So to summarize, our finding is highest fertilizer application did not result in significantly increased yield. So highest fertilization with phosphorus did not result in significantly increased yield. Balanced PK produced the highest productivity, and P has significant while K has a little bit slight yield advantage individually. P and K interaction has synergetic effects on yield, and with increasing fertilizer costs and a conservative approach is recommended to identify fertilizer application rate that may be profitable, and additional research in detailed economic analysis is required. For further references, there are many references regarding fertilizer application. And with this, thank you very much. I appreciate